In this video, we're just going to do one fairly simple example. And before I start, I realize I'm using a term called the altitude in a triangle. What an altitude is, it is a perpendicular dropped from a vertex. We've done that before, and I'm not sure if we called it an altitude or not, but that's all it is. So every triangle has three possible altitudes. You start with one vertex, and you drop a perpendicular from it. That's called an altitude. All right, suppose that we start off with two similar triangles, MNP and SRT. Notice I drew this second one a little bit smaller, but it looks like they have the same angles. So basically, they're the same triangles, only one is smaller than the other. All right, and let's say that the proportionality factor or constant is K, and MA and SB are altitudes of the given triangles. So how do we figure out that? Well, MA, the point A doesn't exist in this triangle yet. So we're going to drop the perpendicular from M down to A, like that. And then SB, the point B doesn't exist yet in this triangle. That's going to be the perpendicular dropped from S down to that, and we're calling that point B. So we know that by definition, when you drop a perpendicular, you have a 90-degree angle. So all we're going to show in all of this, I know that this side, it's like NP is K times this side. NP is K times RT, and so on, because we're given that the proportionality constant or proportionality factor is K. All we're going to show is that this altitude is K times this altitude. And it'll be really easy, I think. Okay. So show that, what I just said, show that MA, that altitude times is equal to, I may have said multiplying it by K. We're gonna do it the other direction, where we're gonna multiply these sides by K to get that. So we just need to show that this altitude is K times this altitude. And note that there are two possibilities for altitudes. We're not going to worry about it. The proof would be the same, but it's possible you could have a triangle like this, and the altitude from this vertex would look like that. And believe me, it would all work out just the same, but I chose to draw it in a nicer way. Okay. We will start off by saying angle P is congruent to what? The reasoning is corresponding angles of similar figures are congruent. So what angle corresponds to this one? Well, this one. The angle P and angle T correspond, and corresponding angles of similar figures are congruent. So angle P is congruent to angle T. All right, what does that tell us? Well, we know that MAP, where's MAP? MAP, that's a right angle, right? MAP is congruent to SBT. Why is that? Because they are both right angles. All right angles are congruent to each other because they all have measures of 90 degrees. And then next we will say that triangle MAP is similar to SBT. Why? Well, angle, similarity. Angle, similarity. If two triangles are such that the two pairs of corresponding angles are congruent, well, you know the third one is congruent, and we know that those triangles are similar. All right, so the next two statements just come from similar triangles with proportionality constant k. We know that MP is equal to k times ST because they are similar triangles with proportionality factor or proportionality constant k. And then the final one is the one we're trying to prove. Same reasoning. MA is equal to k times SB because this triangle and this triangle, this one and this one, are similar.